Alright, this is a Mandelbrot viewer, zoomer, scroller, whatever you want to call it. It's interactive. It uses Pygame for its interactivity. I've been working on it for a couple weeks now, off and on. And I figured maybe if somebody else out there was looking for a Mandelbrot viewer, renderer, and how to write one in Python, maybe this would give them some information that they could use to get started. So I think the best thing to do is just to demonstrate the program, demonstrate some of the commands. So anyone out there that wants to can take this and find out how it works, maybe make some changes and see if it works for them. So I have it pulled up in idle right now, and I'm going to run it. I usually start with Windows 400 by 400, so it doesn't take too long to render. It should come up sort of with the default Mandelbrot view. What you can do now is you can scroll around, you can zoom, and I'm just going to go over the commands as I use them. I'm going to press 2 to increase the scroll rate. The scroll rate starts at 1 pixel, which might be enough for very small windows. And then I'm going to use the arrow keys to move around. I don't update the screen, so this is sort of destructive scrolling, but you can still move the rendering space where you need to in order to render the next view. So let's recenter this, and D is to redraw. And I guess let's zoom in somewhere. So to change the zoom levels, press either 0 or 9. I'm going to press 0 to increase the zoom levels. And you can see that all the commands show up in the shell window there. Let's scroll around a bit more. I don't know, let's zoom in back here. I don't know if I've zoomed in on any of the features back here. I have the iterations set pretty low right now, so it re-renders pretty quickly. Continuing to zoom in. Alright, let's get this guy centered, and let's up the iterations by pressing 6. And you can change the color palette. You can cycle through the color palette by pressing C and then D to redraw each time. Let's see, maybe zoom in on this fella now. Let's up the iterations a bit. And now I'm going to increase the color multiplier. The color multiplier is sort of a hack, so you can get more color cycling. and I pressed 4 to increase the color multiplier. Decreasing the color multiplier is 3. You can also change between two different coloring algorithms by pressing A and then D for redraw. That's too much color cycling there, so I'd press 3 to decrease the color multiplier. Maybe cycle through the color palettes, see if I can get something a bit more appealing. That's pretty cool. Maybe increase the color multiplier. That's not bad. I guess that's pretty much a demonstration of the capabilities of the program. You can also press P to get a printout of where you're at as far as the rendering view. And maybe I should just talk a bit about the program now, or before that, I think what I'll do is I'll just show some of the images that I've captured with this program. That's pretty cool. That's a palette that I just sort of consider a cotton candy type color palette. I call that the fire palette. That's RGB palette. I also use this image in a recent song I made. I really like that one. That one's really cool. That's pretty cool too. I like that one too. That's maybe around the seahorses or on the other side, apart from what they call the seahorses, perhaps. So you can get some really cool images with this. And again, I like it because it's interactive. Oh, and one thing, it's not that efficient when it's just sitting here. So it's probably not that great to leave it running because Pygame continually updates the screen. And I think it's pretty CPU intensive even when it's just sitting here. Some points of interest in the code. One point would be, here's where you define the palettes, and these are the RGB colors and the indices from 0 to 1. So you can define your own palettes and just put them in here, and as long as the indices, the number of indices match up with the number of colors, you should be good to go. I usually do 400 by 400 because that's sort of a good trade-off on my old laptop. Doesn't take too long to render. I've done some optimization using Numba. So you can see the requires up here at the top. The C profile, it's not necessary. I profiled the main draw function, but I don't think that's absolutely necessary to run in its current state. But you do need to have numpy. I'm trying to wonder if I still use numpy. I'm not sure, but I've pretty much gone as far as I'm going to go with this program. It started from another demonstration / program that I saw on YouTube, and I've gotten this version to run quite a bit faster, and additionally use Pygame so that you can interact with it. The main method is the main Mandelbrot method, if you're looking for it. Mandelbrot, however you pronounce it. The main method is right here. This is the main part of the mathematics involved. And I was able to get Numba to recognize that as a method that could be just in time compiled. The first part of the source code is the Mandelbrot class, and most of these functions here are just for changing parameters from the keyboard, changing the zoom factor, the scroll rate, color multiplier, all of those things. And then the more general part of the program is below that. And you can probably uncomment that and comment this line out if you want to profile it. Try to increase the speed. You can press S to save the image as a PNG. This program started pretty small using another graphics library entirely, which was very, very slow. And so I'm happy with how far I've come with it. And like I said, I thought I'd just put it out there, and somebody else looking to see how you do Mandelbrot in Python, maybe it would help them out. And this is also pretty neat in the way that it's interactive. You know, it's not too fancy. It doesn't have the anti-aliasing or any of that stuff. But you can change a lot of the parameters your own. And what do we got? You know, a couple hundred lines. And even a good bit of that is just, you know, getting input from the keyboard. Probably, you know, some of the stuff that might be a little bit difficult to comprehend right off the bat would be my color methods, which are sort of hacks, but you know, I'm getting some color combinations that, or some color smoothing that I don't necessarily see anywhere else. And I just hacked around. This is actually the method that does the interpolation between the RGB triplets and the indices. But the other method that actually chooses the color algorithm to change between the different colors, I think this is it right here. And this is, you know, it's not sophisticated like gamma correction or anything like that. It's just some multiplying and dividing, and it looks good enough. But then again, what you'll find when you change between the two different color algorithms, you might have to increase the color multiplier a lot or decrease it quite a bit. And you'll have to do that more so as you zoom into the image, as you decrease the size of the rendering space. So yeah, that's it. You know, have fun with it. Let me know if you can make improvements in it. There might be some one-off errors somewhere, but you know, I'm getting some neat images, and that's what it's about. It's fun to scroll and zoom around, see what you can come up with. So yeah, have a good one. I'm going to put a link to the code, I guess, somewhere down below, you know, in the description or something. Later.